Today we're going to be using percents to write different equations. You've seen this before with markups and markdowns. It's what we've been working on. But the 7th grade standard does not say that you can just find a total when you're given a markup or a markdown. The 7th grade standard says you have to be able to write multiple equations to be able to find the new amount with any given amount. So that's really what we're looking for today. The goal of all of this is to use x to represent any original amount. So even if you're not given the original amount, you can use x, plug in a given amount later, and find any different new price. So step 1, you're going to label the amount that each 10 block represents. And today you're going to be given 10 blocks just like this one. Step 2, you're either going to color or shade in the amount that you will pay. Each 10 block, because there's 10 of those blocks, each block represents 10%, so you'll shade each percent from the left to right, because that's what makes sense, for the percent that you will pay. Step 3, you're going to find the amount that you will pay after each discount, or if it's a markup, then you'll find the new amount that you pay after your tax, your tip, your markup, whatever that is. Step 4 is going to be the first equation that you write. Your first equation is going to be using addition, if it's a markup, or subtraction if it's a markdown. And once again, you're always going to use x for your original amount when you write those equations. Step 5 is going to be the second equation you will write, and it's going to be an equation to represent the percent change to the original amount. So for instance, if you have something that has a 20% discount, you're paying the remainder 80%. That's the percent change that I'm talking about. Step 6, you'll plug your original amount into each equation. So that's your x value. You'll plug it in to check. Come up here to example 1. It says a PlayStation game originally priced at $50 is on sale for 10% off. What is the sale price of the game? Well, if you have 10 blocks, those 10 blocks represent 100%. Each block represents 10% of the price. 10% of 50 you should be able to do in your head fairly quickly. If you need a reminder of how to do that, your decimal point starts over here behind the 0. To find 10%, you move your decimal point over one space. So each block, or each 10%, is $5. Label each box $5. Every single block all the way across. And if we count back through to double check, we end up with 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The total 100% was $50. But if it's on sale for 10% off, we're paying the remainder 90%. So I'm going to shade 9 blocks to represent 90% of that original price. Now I can count back through to find my new price. 5, 10, 15, 20, 25, 30, 35, 40, 45. The new cost of the game after the discount is $45. It's not enough that I can just find the discount. Now I need to be able to write an equation with subtraction. So I had 100% of the total, and I subtracted 10% of the total. So anytime you're finding the percent of a number, you take your percent, you change it to a decimal, and you multiply. So I've written the percent the side of my variable. Keep in mind that variable represents the original price. If I have 10% of x, I move my decimal point over 2 places, and I end up with 1x. So we write that just as x. 10%, I move my decimal point over 2 spaces, and I end up with 0.1x. So what that means is I have my 100% and I subtracted 10%. I'm going to plug my original amount, which was $50, in for each of these x's to check my answer. Once I do that, I'll be able to check with my next equation as well and make sure that they end up with be the same. So I had, anywhere I have an x, I'm going to put a 50 because that was my original amount. So I have $50 minus 0.1 times 50. 0.1 times 50 is 5. So 50 minus 5 is $45, which matched my answer up top. My first equation checks out. It's correct. I have another one that I have to write though. Now I'm going to look for the overall change to my original amount. Well, if I took 10% away, I'm left paying 90% of the original value. Keep in mind, X represents the original value, so I'm paying 90% of the original. I move my decimal point over 2 spaces and end up with 0.9x. I'm going to plug that in with my original value to check. So 0.9 times 50. You can break out your handy dandy calculators for that. 0.9 times 50 gives me $45. And once again, my answer checks out. Markups are just a little bit different, and you'll see down here, I've given you two 10-block bars. So it says a sweater is marked up 40% of the original price. If the sweater was $30, what is the sale price of the sweater before tax? So I'm only giving you simple amounts here. This whole big block here, all of it, represents the original cost of the sweater. So I still have to pay the original cost, but because it's a markup, I have to pay something in addition to that. So each of these 10 blocks down here represent 10% of 30. Once again, I take my decimal point, move it over 1 space. So each of these represents $3. Go ahead and plug a 3 in on each of those boxes. And it's marked up 40%. So I'm paying this 100% here, which is the $30, plus another 40%. Each of these blocks represents 10%. So that's another 1, 2, 3, 4 boxes. So I have the total of 30, but then here I'm going to count by 3. So 3, 6, 9, 12. I have the original $30 plus my $12 increase, and that sweater will cost $42 after the store has marked it up. Now I'm going to go through and I'm going to write an equation. This time, because it's a markup, it'll be an equation with addition. So I had my original amount, which was the 100% of X. I'm going to pay the $30 that the store paid, but then they're also going to charge me 40% of that original amount. I change both decimals to a percent, so I move my decimal over 2 spaces, and I end up with 1x, which we just write as x, plus, I take my decimal point, move it over 2 spaces, 0.4x. X plus 4/10 of x is my final amount. I'm going to plug in to check. So keep in mind, x represents my original amount, so I'm going to plug in 30 plus 0.4 times 30. Your handy dandy calculator will help you out again here. So 0.4 times 30 is $12 plus the $30 that we originally spent. 30 plus 12 is 42. So my answer checks out. Now I'm going to write an equation to represent the overall change. My overall change is going to be more than 100% because it was a markup. So I had the 100% that I spent just for the original price plus 40%. Well, 100% plus the markup of 40% is 140% of x. Move your decimal point over 2 spaces, and it's 1.4x. I'm going to plug in to double check. So 1.4 times 30, again with the handy dandy calculator, 1.4 times 30 gives you $42. So once again, my answer is correct. For your check today, I just need 2 different equations. Plug them in. That's not what the question asks. You can find the total cost, but I want one equation. This is going to be a discount with subtraction, and then one to represent the total change. You can use those equations to check the original price, with the original price to double check and make sure it's correct, but you're writing 2 equations for your check.